everybody who just joined to us. My name is Andrei Kudoshin. I'm from Elsevier, from the Life Science Department. And today we will have a very interesting webinar, which would be focused on the support of chemistry-related research and how this research can help with environment and energy pillars of Vision 2030. During the webinar, we will cover several big topics. The first topic will cover the green chemistry topic, the idea of the green chemistry, where it comes from, the 12 principles of green chemistry, and the key idea how excerpted and curated data from Reaxys can help to implement these principles of green chemistry in the Egyptian research. It would be like a first pillar from the webinar. The second pillar of the webinar would be focused on the online training and demonstration and guiding you how to use Reaxys, how to search in Reaxys. We will talk about quick search. We will talk about query builder, how to work with your search results, how to work with history, with filters, with export, how to use synthesis planner if you would like to use it. And third, one of the biggest pillars would be related to some specific and particular workflows. Workflows which can help to implement principles of green chemistry and green chemical approach to the Egyptian research. So we will cover the issues of environment chemistry. We will cover the issues of oil and gas chemistry. Particularly, the first workflow would be related to preventing waste, maximizing atom economy. It's one of the interesting topics and ideas of green chemistry. How we can use safer solvents and reaction conditions, increasing energy efficiency, using catalysts instead of stoichiometric agents. We will talk about green reactions of green chemistry. We will talk about degradation of volatile chemical compounds. We will talk about persistent organic pollutants, particularly polychlorinated biphenyls, the environment data and removal strategies. We even will talk how to search some information in Reaxys using the author name. Also, we will spend some time discussing environment-friendly solvents. It's one of the leading topics in green chemistry. Particularly, we will talk about ionic liquids, we will talk about supercritical fluids. We will talk about Reaxys for petrochemical and chemical industry application. And as a logical next step after this, we will talk about hydrocarbon impurities around the Egypt and how to find this information in Reaxys. Even this kind of information available there. So also we will talk about water treatment, about water analysis, and another analytical chemistry techniques and approaches. If you have any question during the webinar, please feel free to raise them. In the Zoom environment and applications, there is a special button which is looks like Q&A, question and answers. Please click this button and you can raise the question anytime during the presentation. Also, I want to mention that for all participants of this webinar, they can go to the Research Academy, use this special code, and on the Research Academy website, you would be available to download additional materials like user guides, how to use Reaxys, how to use Reaxys medicinal chemistry, how to find reaction and physicochemical data, and you would be able to download your certificate. This webinar is conducted as a part of series of life science webinar together by Elsevier and Egyptian Knowledge Bank, which is connected to the fact that Elsevier together with EKB opens the access to two databases. The database, one of them is Reaxys, is the main focus of today's webinar. Tomorrow we will talk about database Embase. This database can help with writing high quality systematic review and clinical trials and innovative treatments and improvement of decision making in clinical practice. So as you see, it would be really medicine dedicated webinar. Today we have chemistry dedicated webinar. We already done 3 other webinars, which was focused on the research related to agricultural industry, food industry, and technologies related. We also done webinar about high quality systematic review, and very interesting webinar last week was done related to the drugs, to generic and novel drugs, synthesis of bioactive compounds, their properties, their bioactivities. So if you find some interesting topic today and want to know more about Reaxys, and for example, would like to see recording of today's webinar, I encourage you to visit this website, elsevierafrica.org/Reaxys. On this website, it's Reaxys landing page, which is developed specially for the access to Reaxys related to EKB. Oh, unfortunately, I'm not able to open it right now, but I hope my colleagues can show it and help with it. And on this website, you also can get the link to Reaxys. And on this website, this one focused on Embase, this one focused on the Reaxys, you can find the recordings of the webinar. So first agricultural webinar is already available. Webinar about drug research and development already available in the Reaxys. High quality systematic review also available on the Embase page. And from now, I would like to give the word to my colleague, Shalan Halat, who is a customer consultant in Elsevier, focusing on the Africa region. So he would be able to explain you a little bit how you can use EKB portal to get the access to Reaxys and Embase. You're welcome.
Thank you, Andre. Good afternoon, everyone. My name is Khaled Chalan. I'm Elsevier customer consultant specialized in core research solutions. These are Science Direct, Scopus, and Mendeley, and together I'm joining efforts with my colleagues, Dr. Andre and Dr. Alexei, just to give you a bit of a demonstration on how you can access all Elsevier solutions that are provided by the Egyptian Knowledge Bank using the EKB portal. So, so just let me start sharing my screen. So as Andre was trying to say a bit earlier, so there is a web page that we have dedicated for Reaxys to be able to access all the resources that are being part of the partnership between EKB and Elsevier regarding Reaxys and Embase. It's elsevierafrica.org/Reaxys. So you can find more solutions, more data about the solution itself, as well as the upcoming webinars and the recordings for the previous webinars as well. So that's first thing, and you can also subscribe for a newsletter to get the most recent update from Reaxys. There is a similar sister page for Embase, working similarly, so even the design is a bit mirrored, so you can find the same details in the same places exactly for the upcoming webinars as well as the recorded webinars for the previous days, and you can also subscribe for an Embase newsletter as well. So back to EKB. What is EKB? The Egyptian Knowledge Bank is one of the world's largest digital libraries. By order of the EKB, the Egyptian government is providing access for content as well as smart solutions for Egyptian citizens, for Egyptian academics and academic researchers, and as well as different types of Egyptian users. The idea is to enable knowledge for all Egyptians just by using their national ID. So there are four main portals when it comes to the Egyptian Knowledge Bank. So it's an initiative that was launched in 2014. EKB was actually started being online starting 1st of 2016. There are four main portals that are related to EKB for public, for university professors and students, for students and educators, and for children age 6 to 14. The ones that will be more relevant to us now or to our topic today would be the public portal and the university professors and students portal, or the academic portal. The public reader portal means requires only a national ID and a working email. But just remember one thing, since you are using your national ID, you cannot create multiple accounts with the same national ID. That means that every Egyptian citizen gets just one account on EKB. However, accounts can be upgraded from one level to the other. The foremost or the top level or the highest portal used on the EKB or the Egyptian Knowledge Bank is the academic portal, and it is dedicated for universities and scientific research. So you can actually sign up as a student, a university student, or you can sign up as an academic staff, a researcher at a university or one of the research institutions in Egypt. And you can have more access to more solutions actually, and you can still have access to all other portals as well. Just as a quick reference, students and educators, that's the portal that's designated for primary to secondary education, like school education. And this one are just resources for kids. All of these resources are part of subscriptions, and they are very unique, that they are being provided to all citizens in Egypt specifically as well. So if we go, how do I create an account? So I'd register to one of EKB's four main portals. Scientific research and higher education would be my best choice if I can satisfy the criteria. So if I click on scientific research and higher education and I click on next, there are two other options, either a university student or university and research center staff members, as I said earlier. Just remember that university students, because of the lockdown for the COVID and the need to shift undergraduate education and postgraduate education to being completely online, there aren't much restrictions to prove that a student would need to prove that he's a university student. Originally, they would need to supply details like their student ID and stuff like that. Now make things are a bit easier. For university and research centers, it's one of two ways of confirming that I'm a research center staff member. The first one would be if it will read my IP or detect my IP, and it will give me a message that this is dedicated for university and research center staff members. So since my IP was not detected to be my institution, so because I'm not connected to an institutional IP or an internet connection provided by the institution directly, it's giving me this message. It can be overridden if I click here. If I have an email ending with edu.eg for universities, sci.eg for research centers, gov.eg for different governmental institutions, and PLP for the Presidential Leadership Program. So if I have an email ending with one of those four email domain extensions, I should be able to override the requirement for being connected to the university or the institution internet network, and to register my account. It will ask me for first name, last name, email, confirm email, mobile number, national ID, and birthday. Once I click on next, it will ask me then for my professional affiliation, whether I'm a student or a staff member, and I'll have to give more details about my professional affiliation. The step afterwards, I will have a captcha, like an image with numbers that I will need to confirm, and I will be sent a confirmation email to my inbox. If you are trying to register and you've received that email and you can't find it in your inbox, please check your junk or spam folder. Also, you have to confirm your registration within 72 hours before, otherwise your registration will be expired. And the last thing I would need to add in here is that this entire website does not work outside Egypt, since I'm based in the Africa office in Cairo. This is why I'm able to show you how EKB looks like. Andre and Alexei cannot get access to ekb.eg because this website only works within Egypt. Also, you'll find that during the entire registration process, you did not insert a password. You will be sent a password that will be used only one time. So when I register, my confirmation email has a one-time password that I will need to use to confirm my registration. Once I confirm my registration, I can put in the password I would need to do. And another thing as well, if I created a reader account, these are all the details I would need to insert solely. And if I created a reader email and later on I have access to my institution internet network, then I can upgrade to researcher, or I can change the email to put an academic email because I had problems with accessing it, for example. So you can always upgrade from reader to academic researcher as well. So once you are signed in, and so this is how EKB would look like signed in, and I'm signed into a researcher account. And you can see that should be the landing page. The academic search engine that you see online takes your search query and runs it against all databases and resources available by EKB. Very powerful tool, but I would recommend you use it if you are looking for something very, very specific. Otherwise, there are solutions that are built in with a lot of features for literature discovery and for finding out, doing your literature review and doing your search for academic papers and resources, other resources as well, as you will see with our webinars. If I go to sources and I click on all sources, and let me just magnify the screen a bit. And so from sources, if I click on all sources, I should be seeing the name of all the publishers and content providers that are available by EKB. For my portal, which is Scientific Research and Higher Education, um, so you can see all of these are the names of the publishers being included in EKB. Um, so um, as you scroll forward, you'll find that they are are arranged alphabetically. So Elsevier would be lying in E. If I click on Elsevier, I can see the list of solutions being provided by Elsevier: Science Direct textbooks, Scopus database, Clinical Key, Backfiles for journals, EI Compendix, and Geofacets database. And I just need you to notice that there are some Elsevier solutions that are not listed under Elsevier and are listed separately. These would be, so Clinical Key is already mentioned here, and it's mentioned separately as well. But if you need to access Science Direct or Scopus, or for example, you would need to go under Elsevier. However, Embase, as you can see here, is listed alone because Embase is available for a limited period, as well as, if I scroll down a bit more, novel for engineering, and the topic of our discussion today, Reaxys. If I click on Reaxys, I can see a description for Reaxys and a link. If I click on this link, it will take me to Reaxys, and I will be given access to Reaxys, as well as Reaxys medicinal chemistry that's being provided by EKB till the end of July. Also, one of the exceptions that are not on the same page here on EKB is SciVal, which is accessible only to researcher accounts. SciVal is not accessible to reader accounts. However, with the current setup, reader accounts can access Reaxys and Novel and Embase and all Elsevier solutions listed under Elsevier here. So once again, once you are onto EKB and you're signed in, you go to sources, you select all sources, you scroll down. If I need to use Reaxys, I scroll down till I find Reaxys with the R. I click on Reaxys. There is a description of what Reaxys does, and I click on this link. It takes me to Reaxys. So as you can see here, so it is signing into Reaxys. I might need to refresh. I believe it might be a conflict with internet configurations that I've had since, yeah, so it is working now. So welcome to Reaxys choice screen. Log in. I would be logging in using the Egyptian Knowledge Bank library. And now I can fully use Reaxys, which is gonna be the topic of our discussion today. So this is where I leave it off to Andre, who will take us on the next of our presentation today. Dr. Alexei as well will be handling your questions. Please direct the questions you have to the Q&A button that you see on screen, any technical questions you have, and we'll be responding to those. Thank you so much. And I'll be stopping sharing and turning the mic back again to Dr. Andre.
Thank you so much, Khalid, for a very nice introduction and explaining how to access to Reaxys and to Embase using the EKB website. As some colleagues ask, now I'm sharing the screen how to access the webinars. So this is the registration links to ongoing webinars. If you would like to watch the webinars which already happened, I advise you to go by one of these links. So for Reaxys webinars, you can go over there. For Embase webinars, you can go over there. And in Reaxys webinars, you will find this one, and this one. So agricultural, drug research, and environment. On the Embase webinar, you will find the webinar about systematic review. We will find the webinar about the drugs because it covers both products, Embase and Reaxys. And after a couple of days, after the webinar would happen, we will hope to see the webinar about systematic review as well. So if you are interested to watch the webinars, you are able to make the picture of this screen or type down the Reaxys and Embase landing pages and get the benefits of the webinars and of using the Reaxys. And right now, let's go to our key topic. And today we will start from the green chemistry 12 principles and how the green chemistry is connected to Reaxys. By the EU PAC definition, green chemistry is design of chemical products and processes that reduce or eliminate the use or generation of substances hazardous to humans, animals, plants, and the environment. When people discuss green chemistry and engineering concept of pollution prevention and zero waste, they mean both laboratory and industry scales. And green chemistry encourage the use of both economical and eco-compatible, it's very important, economical and eco-compatible techniques that not only improve the yield, but also bring down the cost of disposal of waste at the end of chemical process. So from the idea of green chemistry by itself, it's really very well aligned with Egypt Vision 2030, which have also energy pillar, which have environment pillar, which have social development pillar, health pillar, and it's a modern approach which is very well developing around the world. On this picture, you can see the number of publications from Scopus published on yearly basis on the topics related to green chemistry. As you see, it's constantly growing, and the original concept and original ideas was born in 90s, and one of the books which is can be called like a Bible of green chemistry, which is called Green Chemistry Theory and Practice from Professor Anastas, is available in the internet, and you can find in Scopus more than 6,600 articles who citing this book. What is the principles by themselves? The first principle is prevent waste. It means that one should design chemical synthesis to prevent waste. Leave no waste to treat on or clean up. I think it's more or less a simple idea to discuss, sometimes not very easy to implement, and we can go to the next ideas. The second principle is maximize atom economy. Design synthesis so that the final product contain the maximum proportion of starting materials, waste few or no atoms. We will discuss this concept later on some examples, and I will show how to use Reaxys to calculate atom economy later. Next principle is design less hazardous chemical synthesis. So one should design synthesis to use and generate substances with little or no toxicity to either humans or environment. And today I will do my best to explain you how to use Reaxys to assess the toxicity of substances and how to find the data about toxicity in the Reaxys. The principle number 4 is and also, by the way, we will talk about chemical reactions for sure. It's principle number 3, it's about synthesis. So we will talk about chemical reactions and how Reaxys can support you in choosing less hazardous chemical synthesis. At the same time, the principle number 4 tells us to design safer chemicals and products. And it means to design chemical products that are fully effective yet have little or no toxicity. And what we will do is we will discuss how to find the toxicity data in Reaxys, as I promised to you. Principle number 5 said to use safe solvents and reaction conditions. And it would be great to avoid using of solvents, separation stage, or other auxiliary chemicals. If you must use these chemicals, use the safest one. And today we will spend a lot of time talking about safe solvents like ionic liquids, like supercritical fluids. The principle number 4 advises us to increase energy efficiency and run chemical reactions at room temperature and pressure when possible. It's more or less clear. I think any chemist who designs the process would be happy to do like this. But what Reaxys can do, Reaxys can give you the information about the catalyst, about solvent, about conditions, so you can easily assess and choose the best way in accordance with the principles. The principle number 7 advises us to use renewable feedstocks. So the starting materials should be renewable rather than depletable, and the source of renewable feedstocks is often agricultural products or waste of other processes. The source of depletable feedstocks is often fossil fuel or mining operation. So we will talk about this as well. We will talk how to find natural products in the Reaxys. The principle number 8 advises us to avoid chemical derivatives and avoid using blocking and protecting group and any temporary modifications if possible. Derivatives use additional reagents and generate waste. And how Reaxys can help with this: when you do plan your synthesis, with Reaxys you can assess several possibilities and you can choose one which not require using blocking or protecting group. In some cases you cannot avoid of it, but I always advise you to use catalysts, not stoichiometric reactions, because I have PhD in catalysis, and also because this is the point of principle number 9 of green chemistry. And by using catalysts, anyone would be able to minimize waste, to leverage value of catalytic reaction. And catalysts are effective in small amounts and can carry out a single reaction many times. They are preferable to stoichiometric reagents, which are used in excess and carry out reactions once only. For anybody who conducts chemical reaction, this idea might be really very clear. The principle number 10 advises us to design chemicals and products which would be able to degrade after use. And we will talk about how to find the biodegradability data in the Reaxys. So with this data, you would be able to design chemical products to break down to innocuous substances after use so that they don't not accumulate in the environment. Even such information available in the Reaxys. Also, principle number 11 is really focused on the analytical chemistry, and it advises us to analyze in real time to prevent pollution. It's a very common idea in modern factories. It's implemented and in use, and it can help you to include in process real-time monitoring and control during synthesis to minimize or eliminate the formation of byproducts. So in Reaxys, you also can find a lot of information related to analytical chemistry, information about spectral methods, about chromatography, which is like a common technique for real-time analysis. And the principle number 12 advises us to minimize even the potential for accidents and to design chemicals and the physical forms to minimize the potential for chemical accidents, including explosions, fires, and release to the environment. I was very surprised, but I found even some information about explosive compounds in Reaxys, and I will try to show you how to do it today. Again, if you have any questions, you can use the Q&A tab and ask your questions there. So with previous principles, with the previous discussion, I think it's become clear that implementation of green chemistry approach can help you to seriously improve your research and your own results. First of all, I think it's clear that green chemistry is really very well connected with material science, with drug research and development, with oil and gas, with environment and water treatment, with agricultural science, but also with synthesis of organic, inorganic, metal organic, and other compounds. In addition to that, I want to highlight that it's very well known topic around the world, and using the principles of green chemistry and promoting these principles would help you to find the collaborators around the world, and also with this, as well as with Reaxys, you can more successfully to apply to the international grants. How this is possible, how Reaxys connected with this. It's become clear that the implementation of green chemistry requires to have very deep domain knowledge about substances, about their properties, how the structure influences the activity, how to carry out the chemical transformation, and all this information is available in the chemical database from Elsevier, which is called Reaxys. Internally, Reaxys contains several databases, and this is one of the reasons why we conduct such webinars, to introduce you how to use Reaxys, what options available in the Reaxys to improve your research. So in the Reaxys, there is the bibliographic database, which cover more than 60 million records, both from journals, more than 16,000 journals, and patents from key patent organizations. Also in the Reaxys, we have substance database, which cover more than 100 million substances. And what is more important, in the substance database, we have properties of the substance. We have more than 500 million of experimental properties in more than 130 subject areas. In addition to that, via EKB website, right now is available the module which is called Reaxys Medicinal Chemistry, which also very highly connected to environment research, because giving the information about toxicity. This module have a lot of information bioactivity of different compounds, about the effects, etc., etc., etc. I see that people start to ask questions, and I would like to remind you to use the Q&A tab instead of using chat. If you raise your question in Q&A tab, they are logged, and we would be able to answer you during the webinar, or can come back to you later by email and answer all your questions. So please use Q&A tab for the questions and not use chat. Thank you. How this is possible and how it looks like. This is a slide which explain you the value of excerpted data. So for example, just for the one compound, cetan, which is well known in petrochemical industry. In Reaxys, we have more than 2,300 excerpted physical properties just for one substance. As you see here, 2,300. All of this information was collected from more than 1,600 articles. So you can imagine how many times researchers will need to spend to understand everything about the molecule, to get the access to this detailed knowledge if he wouldn't have the access to Reaxys. During the webinar, quite often you can see this red text, for example, like this one video searching physicochemical properties of substances. It's not presented here just to advertise you, but on the Research Academy webpage, where you can download your certificate, also the presentation is available. And after downloading the presentation, you can go by this link and see the video about searching the physicochemical properties of substances in the Reaxys. Unfortunately, if we will try to cover all available application and use cases of the Reaxys, we wouldn't fit into our time. So I put some links to persons who are interested in to be able to get benefits, not only from the presentation, not only from the online demonstration, which we will have today, but also from the video, which is recorded by our colleagues. And when you search for these physicochemical properties in Reaxys, the results can look something like this. So what is the idea of these pictures? The experimental properties in Reaxys is very well curated. What does it mean? It means that for properties, we try to present not only the number. For example, over there, we can see the coefficient of self-diffusion. There is some number with units, but also we try to get and to deliver to you the conditions under which this number was obtained, because in different conditions over there, for example, different temperature, we can see that cell diffusion seriously vary. So from these numbers, for example, you can use predictive models using the Reaxys export capabilities, or you can get some insights and understand about the behavior and the logic of the behavior of your compounds. This is very nice slide. It shows different types of available information in the Reaxys. It's not comprehensive. This list is not comprehensive, but as you see, we have huge amount of physical properties: melting point, boiling point, sublimation, refractive index, density. We have physical chemical properties like adsorption, association, autoignitions, electrochemical properties, magnetical properties, crystal properties. We have critical properties about which we will talk later. Mechanochemical properties, for example, thermochemical data, mechanochemical data. We have spectroscopical properties, so you would be able to find the best technique to analyze some compounds. Also, we have bioactivity data, substance effect, targets which interact with the molecule. We have information about substance applications, and we have a very big variety of environment data, like bioaccumulation, biodegradation, etc., and abiotic degradation, stability in soil, oxygen demand. We will focus on this today later. So the key idea of the Reaxys is immediately deliver you the access to the information and give you the answers on the spot on the questions related to chemistry which you may have when you do your research, any kind of research related to chemistry, material science, chemical engineering. And this is the key differentiator of the Reaxys. So all other databases just give you the list of references, but Reaxys deliver you the answers to your questions, scientific questions. And this is exactly what is explained on this slide, because using other solutions, what you get is the list of references, which you need somehow to obtain, you need to read, and you need to compare these results. Only after that you can get the answer. But with Reaxys, you can get the answer directly. So excerpted data from Reaxys save the time for you for getting, reading, and comparing the literature. And what is very important, it's ensure the immediate access to the information about chemical transformation and chemical substance knowledge. So anyone who use researchers Reaxys are able to implement economical and eco-compatible techniques on the benefit of the society. This was the first pillar, and let's go to the online training and basic search functionalities. So again, in this slide, you can see the first screen from the Reaxys. Also, you can find two very nice videos about retrieving scientific information, about using structure editor. But what is the idea? The idea is that in Reaxys, there is several tools to make you able to get your answers as soon as possible. For the big majority of questions, you would be enough to use a text search or to use a structure editor in the quick search tab. But for some of them, for more complicated search queries, or if you would like to get some specific information, I encourage you to use Query Builder. Today we will talk about both of them. And once you use quick search, what's happening? So you type your search, and as a next step, Reaxys give you this intermediate screen. Why it's happened? Because as we discussed in Reaxys, there is several databases, and the quick search is trying to understand the intention of your search and try to search with this intention in available databases. So for example, if you type preparation of cisplatin, system understands that you might be interested in the chemical reaction of cisplatin, particularly preparation, and will bring you chemical reaction. Also, it might be of your interest to get access to the documents related to the preparation of cisplatin. So Reaxys will search for you in the document database. And also, as you see, there is several searches. What's the difference? In the first one, it tried to search with all words you mentioned, preparation and cisplatin. But often may happen that you can misspell something, and it can give you zero results. To avoid this, to guide you how to improve your search, Reaxys separately use different words and word combination for you and search them in different databases. So here you see that there is 9 million of documents related to preparation and 159,000 of documents related to cisplatin. What also is interesting in the Reaxys, I think we can go to the online demonstration. So right now I'm in the Reaxys, and as you see, it's exactly the same like we discussed. Let's try to search something related to preparation of, let's use this cisplatin example, or we can use any other compound. What's happening right now? You see, I type cisplatin not correctly, and as a search results, we got only 45 documents. So we can understand that something goes wrong. It's quite popular compound, and we need to change our search. How we can do it? One of the options is to click here, to click edit. And now we can improve our search. So system recognize the molecule cisplatin and give us 218 reactions. Also, it gives us 23,000 of documents related to the preparation of cisplatin. One of the interesting features of the Reaxys, please be attention, it's not obvious and not trivial, and usually people who not visiting trainings and webinars not aware about it. So it's like a special secret just for you. Here is magic button, which is called Edit and Query Builder. If you click this button, Reaxys will show you how exactly the search is done. So what does it mean? It means that, as you know, there is a lot of synonyms in our language, and the word preparation can be explained in the documents by different way, and Reaxys even help you with this. So from here you see all the synonyms which was used by the Reaxys, like formation, formations, make, making, manufacture, prep, preparation, preparations, prepare, prepared, prep, synthesis, synthesis. What you can do with this useful information? You can say, wow, it's great. Or if you would like to improve it, you can improve it because this is editable. Also, the Reaxys give you all synonyms of the chemical compound. So cisplatin is a drug name, but also it's chemical compound. And as you see, there is huge amount of different names of this compound. So if you like it, you can say wow, or you can change it if you want to improve it. After you do some changes, you will need to click search in one of these databases. So as you are searching in a database, as you are searching by the words, I advise you to search in the document database, because now it has sense. If you will search in other databases, the search will have much less sense. This is our search results. So what is available there? Here you see some filters, and here by this word documents, you can assess in which database this search was carried out. If you see the word documents, it means that you will see the filters related to document databases, which have filters to the index terms. We will talk about index terms in details later, but also there is a filter about publication year. You see, it's quite modern topic, 1,700 papers published about preparation of cisplatin last year. You see the filter related to document type, article, review, patent. If you're interested in patent, it's the best way to access this information. Also, there is link to authors, to patent assignee, journal title. It takes some time because the information is widespread. Also, what you can see there, for example, you can see the title of the article. You can see authors, which also is clickable. You can see this link to abstract. You can click it and see the abstract. And even more, the search terms are highlighted, like by dark gray. Also, there is index terms. Again, we will discuss them later, but you can browse them as well. It's very useful information. From the documents, you can see the substances which was indexed from the documents. And under the substances, you see several icons which are clickable. For example, this icon, view commercial availability, can explain you if these compounds available by some suppliers. So for example, Lab Networks, Ye Molecules, Sigma Aldrich, or Cambridge Soft. Just click and the system will go to the appropriate supplier database, and you should have information about suppliers from this shopping cart. You need to, in Ye Molecules, you need to follow substance, but also you see that information about price of this compound already available. In addition to that, you can increase the size of the molecule. And even rotate it, but this one is flat, someone is 3D. You can view details about the molecule. So details is what is available in Reaxys. Molecular weight, CAS number, Reaxys ID, linear formula, also the available data, what is the amount of physical data, spectral data, other data, bioactivity. Is there any preparation? What is the reactions of this compound? What is the document over there? So if it's of your interest, you always can click view details, and you will go to the page of the molecules. So you see, now we see the word substance here, and filters are different. So these filters relate to the structure search. And the information, detailed information about the molecules are available. Let's come back. Also, another option to get the information about all substances from the mentioned documents is to click there. So this number means that these 23,000 documents cover 164,000 of substances mentioned over there, 200,000 reactions, and about 2,000 of different targets. So by clicking here, you will go to 160,000 substances from these articles. What else is available on this result page, document result page? You can sort them differently. So for example, by relevance, by publication year, which is automatic, by document type, and even cited by. So if you would like to know what is the most cited article about cisplatin, you can sort them by cited by and see this number. This number, by clicking on it, will bring you to the Scopus, and you can see who exactly cite this article, and also additional information about this article. So here it is, 4,000 document. We are right now in Scopus, and for example, you can use country or territory filter. So if there is any researcher from Egypt who was interested in preparation of cisplatin, here it is, 94 documents from Egypt about preparation of cisplatin. So you can assess and use Scopus as well. If we come back to our substances, we can switch to substance view, and we can see quite another filters. So the substance result view allow you to filter them by substructure. So for example, if you are interested to find all molecules with aromatic ring, You can go to that substructure, go to the structure editor, put aromatic ring there, select as substructure, and click limit 2. This will show us all compounds, for example, like benzaldehyde, which contain aromatic ring from our 164 substances, which we see right now. Additional filters available there is substance class. It's different criteria which you can browse to understand more about substances. For example, filter by functional group, by ring classification, by Richter classification. It would be much more convenient to click here, view more. And these substance classes have 3 views, so you can go deeper. For example, if you are interested in all compounds which have sulfur, you just need to click here, or you even can go in more details. 1 sulfur, 2 sulfur, what does mean 2 sulfur? Disulfides, thioacetals is 1 sulfur. You see, there is different number of compounds. And also there is some numbers. The number shows the amount of records available related to this number. So in our 164,000 documents, not documents, substances, we have 17,000 of substances with this bond, carbon, sulfur, and something else. And we have only 619 CH compounds. Again, just choose something and click limit 2, but let's not disturb it while it's filtering for aromatic rings. What also is available here? You can filter by the molecular weight, by the number of fragments, by the availability. What does it mean? It means that one of the options is substance with known preparation. So if you see over there, there is a preparation of the compound. There is compounds which have no preparation and not available for purchase. There is compounds only available for purchase, and compounds is which are approved drugs. So you can choose one of the options from this. Also, Reaxys index information from PubChem, from e-molecules, Lab Network, Sigma, Aldrich. And if you're interested to find more from these databases, you can use these filters as well. Also, there is a filters about available data. So, for example, if you got 1,000 of different phenols and want to get the mass spectroscopy data, you don't want to browse all phenols, only some with mass spectroscopy. You can choose this filter. It looks it was overcomplicated for Reaxys. We can try to do it later. Also, we can filter by document types because not all substances have both patent and articles. You can select only substance with patents, substance with articles, with review, etc. And also there is several filters related to drug likeness, like log P, Ig bond donors, Ig bond acceptors, rotatable bonds, etc. How the physical properties and other properties looks in the Reaxys. For example, benzaldehyde. What do we have here? In the identification, we can get the access to Reaxys record. So it's Reaxys ID, its number of references, its information about substance, its CAS number, molecular formula, but also from here you can access to information about purification, its derivatives, catalyst investigation, related structures and patent specific data. So there is a lot of different Markush structures which cover this molecule, and also substance labels. What I like much more is this one, drug likeness. It might be of interest if this molecule looks like a drug. To answer this question, scientists develop Lipinski rules, and this is the component, and Weber rules. This is a component of the Weber rules, which are predicted properties. And if your molecules is inside of this triangle, it means that the molecule is drug-like. If molecule in some of the axes overcome of this triangle, it means that there is low chance that molecule will looks like a drug. There is bioactivity data, in vitro, in vivo, metabolism, pharmacokinetic, toxicity data, which is our key topic for today. As you see, it have quantitative data and qualitative data, which was collected on even different biological materials. So for example, GUPI, cell variability. Also, you see the effect, toxic, cytotoxic, and benzaldehyde is known to be toxic compound. Also, there is a very big variety of different physical data, melting point, boiling point, chromatography data. So it is well structured, and you easily can find the relevant information. So if you're interested in GC, in HPLC, you can see a lot of reference available, even TLC. So what you need is just to select the good paper, maybe fresh one, maybe highly cited, for example, this one, organic letters. And you can see the abstract. By clicking abstract, you can see the detail. So with this, you can go to the page of this article, see index term, see abstract, see substances which is indexed there. And browse the information which you need, absorption, association, azeotrope. The same, we have different spectral data, and we have other data. Here it is. First of all, physical data, spectral data, and other data. Why I repeat other data 3 times? Because environment information is mainly accumulated over there in the other data. For benzaldehyde, it's exposure assessment, concentration in the environment, transport and distribution in the environment, bioaccumulation, biomonitoring, biomagnification, biodegradation, abiotic degradation, hydrolysis or photolysis, which is not the case for benzaldehyde. Also, there is very interesting information about how this substance is used. And also you can find here isolated from natural sources. So from which natural sources you can find benzaldehyde. So for example, Brassica rapa ripe flower, interesting. Or biodegradation. As you see, biodegradation is very detailed. So you can see the type of biodegradation, inoculum, concentration, temperature, and method. For some other as a method, for example, you can see even the range of concentration. Often you can find the additional information, which techniques was used to justify that it's exactly the compound what you need. Also, there is bioaccumulation data, transport and distribution. So for example, Persian gas particle equilibrium and coefficients. A lot of interesting useful information. So for example, sorption, coefficient of sorption, air, snow, air, soil, adsorption by and sedimentation by seawater. So it's really valuable environmental information. Also, let's finish with this substance record. What is available? Over there, you can see the preparation. It means the reaction where benzaldehyde is a product of reaction. Not always main product, but it should be the product. The reactions give you the ideas in which reaction benzaldehyde participate. So in which reaction you can find the benzaldehyde. Also, it's the targets on which this molecule interact and the documents related to these molecules from which it was indexed. So it's not all the documents where benzaldehyde word appear, but it's only the documents where there is valuable information about this substance. If you want to find all documents related with the words benzaldehyde, I advise you to copy it to query, to go to quick search and type do the search by the word. Interesting, but this word is even used more rarely. As I remember, it was around 100,000 of documents connected to the structure benzaldehyde, but over there we see only 27,000 of documents. So it's different. What else I want you to know about basic functionalities? Also, you might be interested to use history. You can click history and we'll see all your queries which you've done recently. What you can do with them, you can edit them and you can save them. And for sure, you can come back to them. So if you click there, you will come back to this substance. Also, like next important step is a query builder. What is the idea? In Reaxys, there is 500 searchable fields, and all of them is available and accessible from query builder. You can use the structure of molecule. You can use molecular formula. You can search by cast number, or even you can add some information from title abstracts of the document. This is searchable fields. They are connected by some operators. You can change them. So or, and, not, near. And there is searchable fields. So for example, if you're interested to biodegradation, you just need to type it. And this is search. This is the tool to search in the searchable field. It sounds interesting, but the idea is that we have 500 searchable fields, and it sometimes can take a lot of time to find what exactly is relevant for you. But also with these search fields, you can use desired one. So when you found the one you are interested in, you need to drag and drop it over there, and you can use it. So by show fields and high fields, you can put something there, but even this one is useful because you can use find anything. For example, about phenolic compound. So right now we will search information about biodegradation of phenol, and we need to search substances. As you see, we found different variations of phenol. It's C13 phenol, also several mixtures, and all of them have this heat data. It means exactly what we try to search. It is biodegradation data. Okay, let's come back to the presentation. Okay, if we have forgot about something. I think the only what we haven't discussed is expert and synthesis planner. Okay, what is expert? What is expert? From the result page, you can select one or several results by clicking here and export them. You can do it from all search results, from document search results, from substance search results, from reaction search results. Just select it and click export. You can choose the format, PDF, Excel, Word, or even SD, MOL files, RD files, SMILES. Select the range and select exactly what you would like to export. All data, identification only, hit data, or even some specific data. Click export and the export process will start. After the export process is finished, you will see the link download. You will need to click it and you would be able to download the available information. What is synthesis planner? To show you synthesis planner, let's go back to some interesting compound. For example, this one, L-epinephrine. And you might be interested how to synthesize this compound. One of the options is go over there to click preparation, and you will see the single reaction which bring you the L-epinephrine. This reaction search results contain yield, contain reference to journal or to patent. It contains a condition, so the catalyst, solvent, temperature, other condition like inert atmosphere, darkness. It may contain experimental procedure which is excerpted from patent or from key journals. And also it have its own specific filters. It's one way to see single reaction. But also what you can do is to use synthesis planner. To use it, you need to click this icon, choose manual or automatic planning, choose these options, or not choose, just click create plan. And Reaxys will bring you several retrosynthetic plans. So plan number 1, plan number 2, plan number 3. As you see, this one is multi-stage. Plan number 4. Let's imagine that you like this plan but want to know more details how to get this compound or any of them. You always again click this icon and add additional steps. So here it is. For this molecule, you see another steps. And each steps have numbers. So step number 1, number 2, number 3, number 4. And now you can see step 5C, 5B, 5A, because this compound available by several ways. And all of these steps are available with conditions. So in the down, you can see this condition. Step 1 over there, step 2 over there. So you can easily assess if this is a good synthetic route, if this a green synthetic route, if it implement hazardous compounds or not. if it's use available compounds, the compounds which you can synthesize, the reaction have high yield or not, with this very interesting tool which is called synthesis planner over there. Okay, so now we cover second pillar, and let's go to the workflows. And with workflows, we will start with particularly with principles and the principles of green chemistry. And the principles number 1, 2, 5, 6, 8, and 9 are related to reaction data into the Reaxys. And as you may know already, that Reaxys contain 49 million of chemical reactions with detailed information about solvent, yield, catalyst, conditions, etc., etc., etc. So all this information can help you to prevent formation of waste, maximize atom economy, use safer solvents and reaction, increase energy efficiency, avoid chemical derivatives, and use chemical catalysts, not stoichiometric reagents. This slide also gives us some insights about atom economy. What is this? What is the atom economy? For the reaction A plus B gives C plus D, atom economy is mass of the product, C, because we believe that C is desired product, divided onto the mass of C plus mass of D multiplied on 100%. So it's clear that the best atom economy would be happen if there would be no any byproduct, and in this case the atom economy would be 100%. Let's try to consider this approach on the very simple example, imine synthesis in Reaxys. So one of the options, if you want to start from the beginning in Reaxys for synthesis of some molecule, is over the quick search, structure editor, draw your compound. In our case is this one. So you can add the chain. You can add a second ring. After that, you can substitute carbon with nitrogen, and also you can add a double bond over there. So now we have imine. What else we need to mention? We need to explain the reactions that we are interested in the reaction. What differentiate reaction from substance? Reaction need to have arrow. Right now, we set Reaxys that we are interested in reaction, and this molecule should be the product of this reaction. We need to click transfer to query and find the search. And right now, Reaxys give us certain synthetic reaction, exactly like we drawn, but also it advises that there is 39 similar reaction, which include tautomers, some stereoisomers, ring closure certs, etc. What we see in Reaxys search results. For each reaction, you can see different condition. And in the Reaxys, you easily can assess the best and the greenest condition. So for example, this reaction can happen in this condition, 1-butyl-3, blah, 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 in silver 3-fluorometal sulfonate, in the solvent 1,4-dioxane at 70 degrees. I don't think that it's really green. Also, this one goes with another catalyst, and we can check the preparation. Or for this reaction, we see even yield of byproducts. Also, we see catalyst, we see solvent, which is toluene right now, we see sodium hydroxide, and we can assess if this reaction is green or not. In our particular case, for example, for this reaction, how we can assess atom efficiency? Very easily, as we already discussed, we need to click over there. It's our key product. It's highlighted even by blue in the Reaxys, and we can click there and take molecular mass, 181. We should take molecular mass of second product. It's 106. And we need to use very simple equation. 181 over there, 181 plus 106, 63%. So as you see, the yield is not taken into account in atom economy equilibrium. So this one is not the best reaction because even despite of the high yield. In addition to that, we can see that this reaction gives us some waste. At least what is good in it, that there is no chemical derivatives, but as you see, it's carried out in dodecan, and I don't think that it's a safe solvent. The good about it that it uses catalyst. So if we browse reaction, we can try to find something more greener. For example, this reaction. Why this one is more greener? Because from the viewpoint of atom efficiency, there is almost no waste, just water, and atom efficiency is quite high, 90%. And it's not only very high atom efficiency, but also you can see that the yield is very high. And also there is no any waste, no chemical derivatives. Unfortunately, it's carried out in toluene, which is not very safe solvent. It's carried out in comparable high temperature, 80 degrees, but under the room pressure. In Reaxys, all pressure is measured in torrs. This one is room pressure. What makes it is more greener that this one is carried out on the catalyst. So this is how Reaxys reaction data can help you assessing if this Reaxys reaction green or not very green. This one looks much better than previous one, but still, can we improve something? For example, temperature and pressure. We can continue browsing, and for example, we can see this reaction, which also have very high yield, which also have very high atom economy, but which use green solvent, ethanol. Unfortunately, the temperature and pressure is even higher, but I think it's it has sense to switch from the toxic solvent to this very nice ethanol. And to help you, Reaxys index not only condition but also additional data. And for example, you can see it's green chemistry. So this reaction is referred to as a green chemistry reaction. Another green chemistry reaction forming the same compound is presented over there. So it's also green chemistry, and this one carry out even without any catalyst, and with quite easy catalyst. So again, the atom efficiency is quite high, only water is formed, yield is quite high, no waste, no chemical derivatives, and even no solvent, but unfortunately still high pressure. And for example, if over there we don't see any catalyst, and if we're interested in catalyst, it has sense to click abstract and see the abstract. Often the catalyst can be mentioned there. So we see that this is nickel on aluminum catalyst. What else is available? What else is available? So right now we can go to Reaxys and see that over there in filters, you can see some particular solvents. We have very green ethanol, very green water, and other solvents. And we even have solvent classes. One of them is green, so we can choose all green solvents and limit to if you're interested to carry out this reaction in green solvents. So as you see, this one is carried out in water and in ethanol. What is green solvents? By the definition from this article, Green Chemistry and Engineering from 2007, green solvents are environmentally friendly solvents or biosolvents which are derived from processing of agricultural crops. And with this, we can go to the use case related to volatile chemical compounds. What we can do and what we can discuss right now. Right now, it has sense to discuss indexing of the document in Reaxys. If we are interested with volatile chemical compounds, it's not connected with some particular structure, or at least it's not clear from the name what exactly it means. In this case, what I have did, I do the document search in Reaxys. So I try to search for these volatile chemical compounds, and I found 26,000 of documents. And over there, as we already talked, there is filters for index terms. What does it mean, index terms? The Reaxys index full text of the article, and in addition to author keyword, it adds specific keywords which can help you to explore the topic and explore the ideas discussed in the article. And it gives you insights about the article from the several viewpoints. So one of them is engineering, it's compendex terms. Second one is biomedicine, it's M3 terms. And the Reaxys index terms, it's viewpoint of the chemistry. So coming back to the volatile chemical compounds, we can go to these index terms and we will see that from 25,000 of articles about volatile chemical compounds, the 4,000 relate to the oxidation, 3,500 relate to the adsorption, and also on the next page, 800 relate to the biodegradation. So it gives us insights. What is the typical approach which people use related to our topic, particularly volatile chemical compounds? So usually they will try or oxidize them or to adsorb them. And we can go even deeper. So how it looks in the Reaxys. Let's make a quick search. You see index terms. It's all terms indexed in this 25,000 documents. So you can open any of them and see chemical index terms. It's all of them, so you can browse them statistically, oxidation 4,000. Or if you know the specific branch in which you're interested, you can use Reaxys taxonomy tree. Open the filter, click view more, and you will see the index terms connected to Reaxys taxonomy tree and to your topic. What is the branches of this tree? First branch is physical chemical properties. So from there you can see what kind of properties is discussed when people deal with volatile compounds, organic compounds. It's transferred phenomena, clear it's volatile, chemical properties, spectroscopy, phase properties, etc. Second branch is chemical transformation. So from this branch, you can understand how exactly people transform them. Physicochemical analysis give you insight what kind of analytic techniques, including chromatography, are used. And the first one is separation methods, meaning chromatography. Here it is, chromatography. Spectral analysis. So if you're interested in some very, very specific spectral method, this document search is the best case for you. But we are at the beginning interested how to transform our compounds, how to oxidize them. So we can go here, chemical transformation, chemical reaction classes, and we can see that number one is a redox reaction. Number two is combustion. Number three is biochemical reaction, but the amount of papers with this much lower. So if you're interested in oxidation, you can choose this one and combustion and limit 2. And from 25,000 of documents in general about volatile organic compounds, we can focus on some specific topic, on the oxidation. And the Reaxys even guide us what topics are used and how to deep further, how to get to our ideas the faster. What I found when I do the search, that it's often used following oxidation techniques. The number one is electrochemical oxidation. Number two is ozonolysis. And number three is photocatalysis. So these are the most often used oxidation methods of volatile organic compounds. It's happened that I also did my PhD regarding the oxidation of phenyl compound using ozonolysis and using advanced oxidation processes. So I can explain this information for you in some details. So from these reactions, let's go to the oxidation reactions and let's select, for example, ozonolysis. Right now, we have only 251 documents, and by click reaction, we can go to some particular reaction which was explained and connected to volatile organic compound. And it's very logical that this reaction have ozone as one of the reagents. So for example, here you can see ozone in the conditions, and it's very friendly reaction. You see it's done at the room temperature. Here you can see ozone as one of the reagent, and the output is free radicals, which also is very interesting because there would be no insoluble products. The same we can see from over there. So one of the articles focused on photocatalysis, for example, is this one: chemosorbed oxygen on the surface of catalyst improve specific selectivity. So it's exactly the photocatalytic approach. As discussed, by clicking cited 20 times, you can go to Scopus, but also you can choose substance view to see what is the compounds discussed in this article, and you can assess if there is any compound of your interest or no. And again, these buttons are clickable, so you can find additional information. Let's go to the persistent organic pollutants. Before we go to them, I want to explain you how Reaxys substance data can help with the green chemistry principles number 3, 4, 7, 10, 11, and 12. So as you already know, we have 500 million of chemical properties, and the principle number 1 is connected with the bioactivity data, toxicity. The principle number 2 connected with use renewable feedstock. So for example, if you are doing phytopharmacy or some complicated organic molecules, you can go to find if this molecule is available in some natural compounds. We already discussed the bioaccumulation, biodegradation, abiotic degradation, stability in soil, and oxygen demand to cover the principle number 10, design chemicals and products to degrade after use. So with these searchable fields, you can access this information. And also the principle 11 about real-time analysis, and you can use spectral data and chromatography data, preferably even spectral data, but chromatography also okay. And to assess the explosiveness, you can use data. How it looks like, how to use this use data. From Query Builder, you need to clear everything, and now you can go to the searchable field and type here use. You see this search field use, drag and drop it, and here you see the field use pattern. As a use pattern, you can type whatever you want. Corrosion inhibitor, name of the specific disease, name of the properties, desired properties, or even something like explosiveness. But the secret which I would like to share with you is that in all text searchable fields in the Reaxys, we have additional tools like star, which mean any combination of letters and digits, and question mark, which mean any letter or digit, but just only one. So with this, we can cover all the variation, explosion, explosive, explosivity, etc., 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 etc. Just type it here, click substances, and you will find all substances reported to have some explosive activity. You see, it refers to some disorder. When I do the search previously, I got another result, and it gave me an idea that I need to play with this word combination. But let's come back to our topic, and let's come back to persistent organic pollutants. So one of them is polychlorinated biphenyls, which is really a big issue because these phenyls was widely used previously before they was banned, but they are often not biodegradable, and there is a lot of storages of these compounds So it has sense to focus on them and research them more. By this link, you can see some workflow, particularly about biodegradation of PCBs, polychlorinated of biphenyls. And what I would like to explain you, the two strategies, two search strategies, different strategies, how to search information about biodegradation of PCBs in Reaxys. One of them is to use the name and the empirical formula, Brutto formula, which we call it, this one, and also some search groups related to biodegradation. Second one is to use structure, and again with molecular formula and with biodegradation fields. So what we start with? Let's start with molecular formula. Also with, let's add the name. And let's add something about biodegradability. What is the idea? If we are interested in biphenyls, it means in the name somewhere it should be biphenyls. Right now, you can use this star because even before biphenyls there could be some wording. After B, you can use question mark because maybe someone write it with E or with Y. And also let's add phenyl and star again. Over there, we can use any molecular formula, but we can type it, but also we can use this periodic table. So what our biphenyls should have? They should have 12 carbon atoms. They should have hydrogen atoms, but we don't know how much of them. So we put question mark. And they should have some chlorine atoms. Or let's do it more complicated. They can do any atom from this group, and let's put this one, 7A, with unknown amount. Let's use this formula. So we want to search these biphenyls with any halogen atom and with any biodegradation data. It's one approach, and let's search it. So as you see, we not limit our search to graphical structure, to graphical structure. So even if some compound, what does it mean technically? How it will work? So if this word combination biphenyl would be somewhere, we will find it as a search result. In our case, our search was very smart, and we have only relevant results, relevant biphenyl atoms, and you see only one which have biodegradation information, this one. If you don't like to use the chemical name, for example, it's very complicated, you can use the structure. For this end, what you need to do to go to structure editor, use this molecule, use this one, put another aromatic ring. What I also like there is these different types. So for example, this one is different bonds, single bond, double bond, triple bond, single or double bond, this one, cis or trans, double cis trans, aromatic, any type of the bond, or even this one, position variation bond. So you can select group of atoms to which any chlorine would be connected. This is position variation bond. Over there, we have different items. Here, again, we have periodic table. Here we have substitution for some specific items, hydrogen, carbon, etc. Here we have different atoms like any, like halogen, metal ion. Let's put halogen over there. What we code right now, we code biphenyl only with 2 halogen atoms. We can search it as drawn, so it would be particular this structure, or we can search all substructures from this molecule. In our case, it's better to use as drawn, because otherwise we can find some different groups, but which should be limited with other conditions. So again, we found some biphenyls with biodegradation data, but as you see, the search result is different, because now we focused only biphenyls with 2 chlorine atoms. And as discussed, there is a lot of available data covered by other, like exposure assessment, concentration in the environment. For example, these polychlorinated biphenyls was found in the lake Baralas, Egyptian Mediterranean Sea coast. And also the link is available. What else we can see? We can use the literature search and search in documents for the word combination polychlorinated biphenyl removal. And we will find around 900 documents, and analysis of them will show us that one of the key approach is to use bacterial, and the second very often approach is to use chemical removal, particularly to use advanced oxidation process. What is this? It's to use combination of hydrogen peroxide, ozone, ultraviolet, catalyst, or oxygen. So some combination of these very strong oxidation processes. When I prepare a presentation, I remember that I deal with degradation of phenols, ozanolysis of phenols with catalysts. So I have an idea to search my own papers in the Reaxys. And this gives me an idea that some of you may want to find some articles focused on the valuable author whom you know. So you can type the family name of the author in the starting page. It's strategy number 1. Strategy number 2 is to use query builder and to use author search field over there. So you can type something there. And you will get the result. So here it is, some of my articles about catalytic ozonation of lignin and its compound. It's really focused on advanced oxidation processes, especially this one, ozonation of lignin model compounds in aqueous solution catalyzed by manganese ion. If you're interested, you can get more from the paper. And now let's go to the environment-friendly solvents. I think it's quite interesting topic. And when we start to discuss this topic, I want you to go to the another Elsevier database, which is called ScienceDirect. It is full text database with from journals and books published by Elsevier. And in ScienceDirect, we have a special tool, which is called topics. So when you start to search for something, you can find not only particular articles, but even the collection of some specific articles, and which is connected to focus with some topics. And for the ionic liquids, which is one of the well-known green solvents, we have the topic in ScienceDirect. And I really like it, and I want to present it to you because in addition to the name, it has definition, which tell us that ionic liquids are salts which exist as liquids at the temperature below 100 degrees, and they usually composed of combination of organic cation and organic inorganic anion, and even the origin for this definition, and some interesting articles related to this definition. Coming back to the ionic liquids, why I like it, because what I found is this image which give you insights about the most common used anions and cations in ionic liquid. One of them is imidazolium. The advantages of ionic liquids and why they connected to green chemistry is the following. So ionic liquids are fully non-volatile. They can be used as unique reaction media for the wide range of organic or even inorganic reaction. And because of variety of anions and cations, you can adjust solubility for particularly your reaction. And this can give you the opportunity to use them by themselves like a catalyst. So this is exactly the ability to design ionic liquid for specific reaction. They also have very high conductivity, and you can try to get some benefits of it. Ionic liquids can dissolve enzymes, and it can easily help you with formation of biphasic systems for separation of compounds. How to find the ionic liquids in Reaxys? Over there we have some radicals, some anions and cations, not radicals, and we can search all compounds, all salts related to these groups. So one of the most commonly used is imidazolium, and let's go to Reaxys and search for imidazolium. So we go to structure editor. This is one of the secrets. If you don't want to draw something, you can use this one, create the frame, the structure from the name, and we see the imidazolium. Also, we can use the Reaxys generic group, which can substitute the very big variety of chemical molecules. And let's add all imidazolium. The system said us that it's incorrect because the nitrogen cannot have 4 bonds, and I fully agree with him. That's why we need to set that this bond is charged. Okay, now is better. To cover all ionic liquids, we have to take into account these additional filters. For ionic liquids, it's better to remove tautomers, stereoisomers, additional ring closures, isotopes, charges, and radical, but let's keep salts and mixtures for ionic liquids. Also, I would like to explain you this Markush. So by click here, you will get access to the Markush structures, which are widely used in patents. But as it's mainly out of the scope of current webinar, let's discuss it later. So right now we can search for all ionic liquids, and let's do this search. And we found 19,000 of different ionic liquids based only on one cation, imidazolium. As you see, they have physical data, spectral data, they have different reactions, and the variety of ionic liquids is very high. Also, what we can do, but we didn't during the demonstration, we haven't focused on boiling point, because ionic liquids should have boiling point below 100 degrees. But even if we implement this condition to avoid of ionic liquids with boiling point higher than 100, that's why we use not and 100 and more, we still will have 17,000 of them. By this link, you can get additional information how to define Reaxys generic groups. What does they mean, this G atom and other atoms? So it may be interesting for you. And also, as it is used not by themselves, but as a medium, in Reaxys, you can find all reactions which are carried out in ionic liquids. What you need to do for this end is to use specific searchable field. Over there, topics and keywords, there is reaction data and condition. And you can type here whatever you want, whatever you are interested in. For example, ionic liquid. Additionally, you can type, for example, process scale, or for the industrial scale, for industrial scale reaction. You can use HPLC to find some additional chromatography data in the reaction explanation. But right now we found 27,000 of reaction which carried out in ionic liquids. And you can see that a lot of them are really very green because they can carry out in room temperature and without a lot of waste. The next one is environment-friendly solvent is sub and supercritical liquids, fluids, not liquids. It would be more correctly to say fluids. It's usually the CO2 water, methanol or ethanol, which is pressured and temperature above critical point. The advantages of this solvent is its unique solution with hydrophobic or hydrophilic properties, which can be regulated by pressure and temperature. Also by pressure and temperature, you can manage the solubility of different compounds. The viscosity above critical point is very low, so reaction rate is very high. And this is very good media for advanced oxidation processes, which we already discussed, coming back to chlorinated biphenyls. And also, if you deal with particularly water, it's oxidative and base catalyst by itself. So in Reaxys, you can find critical parameters of more than 1,000 substances, but ethanol, CO2, water, maybe ammonia is often used as a media for carrying out reaction. Also in Reaxys, by again using this reaction data, you can find all reaction which can be carried out in supercritical fluids. And as you see, for example, in this case, it can help you to remove CO2 into the valuable product with 100% atom economy and very high yield. So it's really great condition, very green reaction. Or you can browse it and find something more interesting for you, for example, by using this filter by structure. And we need to cover the rest topic which we still have. It's petrochemical industry. So with Reaxys, as participant may understand, any chemist can expand environment-friendly business offering in the market with breakthrough discovering research using Reaxys. What exactly it could be? For example, if you're a petrochemical researcher and you have polypropylene, you can assess what kind of green industries, green processes can be used to get more products from propylene and propylene derivatives. For this end, you will need to use this searchable field reaction data and condition, draw the propylene and put the arrow. So again, this reaction data condition, which is available over there. Query builder, topics and keywords, and reaction data condition. Industry. The secret is if you use just industry scale, these words should appear somewhere in the text. But if you put the operator next, they should be follow one each other. So this search will bring you the reaction which explained as an industry scale reactions. And this industry scale reaction is could be used to define new potential products for petrochemical or chemical industry. So, for example, from propylene in Reaxys, we can find more than 25 different industry scale processes, and all of the product, for example, like this one, have additional information to assess its purity by spectral data, by chromatography data. You can use abiotic degradation data, biodegradation to assess if these compounds are green. You also can leverage from the application information to understand how to use these compounds. If we are covering petrochemical industry, we need to talk about hydrocarbon impurities around Egypt. So how to code this in Reaxys? We will need to use molecular formula and the concentration in the environment. Molecular formula. So any hydrocarbon and environment, concentration in the environment. When we get it, when we open the fields, we will see location. So we can find any data about concentration on the environment about hydrocarbon, or we can specify it to the Egypt. Also, we can choose instead of is contain. It means that somewhere in this field there should be word Egypt. So we can do the search. We found 61 compounds. As you see that they are quite toxic. You can browse them and find the additional information about their concentration in the environment, like in beef, in chicken, in specific region on the north of the country. You have the methods, how it was measured. You have the link to the author. As you see, it's very well cited. And for all these compounds, you can assess their toxicity bioactivity by using the heat map. What you need to do? You need to click heat map and to select axis. Select axis. What does it mean? The heat map will bring you the diagram. On one of the axes there would be different substances, 61 which we found, and on the other axis we can choose. Let's choose the effect. Additional options are target, biological target, species, biological species, but let's choose effect. And we can see the bioactivity of all our 61 compounds. As you see, there is quite different bioactivity. For example, carcinogenic one, cytotoxic one, even death. You can find genotoxic activity. There is hepatotoxic activity, mutagenic activity, and all of this information is even sortable. So if you would like to find the most dangerous from the viewpoint of cytotoxicity, you can sort it by the activity. just click there and you will see the cytotoxicity that most dangerous compound, this one, have highest cytotoxicity 10. 1 is means that there is almost no cytotoxicity measured. If you want to know more details about this number, just click on it and you will see the details, the quantitative results, IC50, which exactly parameter was measured, what is the value, what was the unit, etc., etc., etc. What else we have not discussed? We can use Reaxys for water treatment, and I advise you to start from the literature search using the Reaxys. So for example, you can type in search Reaxys water treatment. We already did this several times, so I wouldn't show you how it looks. And also we already discussed about Reaxys indexing terms, which cover engineering viewpoint, biomedicine viewpoint, chemistry viewpoint. So from the search results of water treatment, one can find 150,000 of documents, and the index terms can be used to assess what is the approaches widely used in the water treatment. One of them is coagulation, and the coagulation indeed is known to be drinking water treatment, one of the stages in drinking water treatment. Also, you can use the Reaxys tree to assess what is chemical reaction, what is the method analysis, what is the physicochemical properties. So again, you can revise it by browsing the presentation downloaded from Research Academy. One of the stages which is often used for the water treatment is water demulsification, and you can search for the water demulsification again for the documents to find the concept which is often used, or also you can find the substance which is often used as demulsifiers. From this end, what you will need to go to Query Builder to find this search result use, and make this very fast search. So with this, you can find a substance which is explained and described as demulsifiers. So this one is lubricant oil demulsifier. As you see, often the mixtures or some even polymer compounds used as demulsifier, and Reaxys covers the data as well. And last but not least is searching of analytical chemistry data. There is two approaches. One of them is to fully type your search in the search Reaxys, for example, HPLC of phenols. For some specific words like spectroscopy, UV spectroscopy, HPLC, chromatography, Reaxys will recognize it as a specific property and will give you the search. So with this HPLC of phenols, you can find 137,000 of substances which are phenol derivatives and have HPLC properties. Or you can use a structure editor from the first page search Reaxys to put the different phenols, some particular phenols, and you can try to play with coding the property of your interest, HPLC, for example. So this one will bring you only 4 substances, and depend on what you are interested in. Sometimes it's better to have 4 substances instead of reading a lot of information about thousands of them. And like the strategy number 3 is to use query builder, and this one is one of the most practical. I just want to show you the spectral data. Here it is different spectroscopy data or even chromatography. Or even some chromatography data. So now we search and see that Reaxys have chromatography data for 1,600,000 of compounds. So each of these compounds have some chromatography data. For example, aniline, different data, which also have direct relation to the environment, because you somehow need to have best practices to analyze different compounds. And even more, another interesting topic related to environment is adsorption of heavy metals or anything else or any compounds. It's important to mention about it because it's really important topic in some countries. So what we have in Reaxys, we have adsorption field. And for example, for heavy metals, you can use it together with molecular formula. In molecular formula, you can put some specific metals, for example, plumbum. Or you can specify it like transition metals, post-transition metal. Don't forget to use star to set the system that it's different kind of molecules, not plumbum by itself. And also you can use this one, any kind of adsorption data. With this, you can find the information about adsorption of about 100 lead derivatives. So for example, this one, and it's very detailed. You can see from the solvent from which it is absorbed, the temperature, and what is more important, the partner. And this partner can give you the ideas, how to remove these toxic heavy metal ions from your solution to purify the water. So finally we finished all the use cases which I prepared for you, and now we are ready for the questions. And now I am showing you the slide which some people ask me to show again. What is this? This one is the link to Research Academy, and this one is the code which one can use to get certificate, to download the presentation, and to download the additional materials. And I am showing you this slide, and let's start to answering the question. So one of the question, if can we send the presentation or the link to green chemistry principles? The presentation is available by Research Academy. Just go to this website and put the code. Another question, is it available on EKB? Yes, Reaxys is right now available on EKB, and it would be available till the end of July. Reaxys is an amazing platform for researchers. It saves money and time. We need it for permanent access on EKB, not only as a trial. Is it possible? Well, colleagues, this was the question. And what I can advise you according to this, you can contact Elsevier and mention this to EKB, some participants, some members, that you are interested in the product, that you really like the product. And if you can encourage your dean or even the vice rector or rector to sign the official request about it, submit official feedback about the Reaxys, it will seriously strengthen your request. I see that some participants trying to use chat. Please use Q&A tab so we can answer you later if we wouldn't be able to answer you right now. One of the questions go to drug likeness. If compound not present in the triangle, it is not a drug-like? Yes, exactly. If the compound is go outside of the drug-like triangle, it means that according to the Lipinski rule and Weber rule, the molecule do not looks like a drug. It don't obligatory mean that it's not approved as a drug. There is some exceptions, but usually this rule is followed. So usually this molecules is not the drugs. How Reaxys can be useful in field of natural products. We haven't covered this in the presentation. I can show you. So what we have over there, we have searchable field, natural products, isolated from natural products. And what we can use there, we can use any natural source over there. So we can type the specific name of the plant. We can type specific insect, specific animal, for example. We can even type human, and we will find some substances which was detected in the human beings. For example, in case of doxorubicin, it can guide us to its antibiotics. It can guide us to the detection technique of this compound in the urine. So you see it's human urine. So one of the type of pines have the name Pinus sylvestrum, and we can try to search compounds which was found in it, Pinus. There is more than 1,000 of different compounds which was found in different Pinus. So you see, it's different plants, and these compounds was found in them. Quercetol is quite interesting compound. For example, it can be found in Pinus siberica. So this information is extremely useful for the phytochemicals and phyto drug development. And again, the slide about Research Academy, and come back to the questions. Does Reaxys contain data about nanoparticles? Reaxys contain different records to compounds which are presented in different crystal structure. What does it mean? So, for example, we can search for aluminium 203 and found 173 substances. What would be the difference between them? One of them have gamma structure, one of them is corund and have alpha structure, one of them is sapphire. All of them have different properties, and you see physical properties, crystal phase. And these are the different substances from the viewpoint of Reaxys. So from this point of view, Reaxys cover different nanoparticles. Also, if you are interested in catalysis application of nanoparticles, you can use the filter of, for example, this one, but we need some organic reaction. Let's go to the history. Let's choose some reaction, for example, this one. So when we have a lot of reaction, you can go over there. Catalyst classes, active center, and you see different items. So if you're interested in catalyst focused, for example, in platinum, just select it and you will limit search results only to the reactions where the platinum is the catalyst. This includes the crude platinum, some platinum oxide, and also the nanoparticles of platinum or on other ground. Can we search for our compounds if it is reported or not before start synthesis? Yes, exactly. So you can go to the structure editor and try to search this compound. Do Reaxys contain the health hazard of chemicals and how to deal with them in safe way? Yes, for example, for let's go to the history, or it would be easier to find phenol by ourselves. In the bioactivity, you can see toxicity and safety, and there would be available even some data from MSDS. LD, LD50, LD50, and also one of them is belong to MSDS. Here it is, material safety data, LD50. What else do we have? What else do we have? If we have any other questions, how we can prolong access to Reaxys? As I explained, you can contact EQB, and it's better to ask your dean or vice rector or vice president to submit official letter. It looks that we cover all Q&A questions. What do we have in chat? In chat, we also covered the questions, all the questions, and I think what we can do right now is to show again our landing page, where you still can register to the webinar, which will happen tomorrow, which would be focused on the M-based biomedical database for high quality systematic review. Also from this page, you can find the links to Reaxys landing page. This one, elsevierafrica.org/Reaxys/. where you can watch the recordings of the first 2 Reaxys webinar for the agricultural research, for the drug development. They already available by these links, and I keep this slide for you for a couple of minutes, so you would be able to make a picture of it, maybe by your computer or by your iPhone or any other mobile phone. And from this, we are very close to finish our webinar, and maybe my colleagues, Alexei or Khalid, have any comments, ideas, suggestions. When they're thinking, I would again want to say thank you so much for visiting our webinars, and we highly appreciate your interest, your participation, and encourage you to get benefits of having Reaxys right now.
From my side is only one suggestion. Come to my tomorrow webinar related to Embase.
Someone asked about the links to certificate, and I put the links to the landing page into the chat, to the landing page to the Reaxys, landing page of Embase, landing Research Academy link, and the code which you need to use to get the certificate. All of them are available in the chat right now. So, dear colleagues, do you have any other questions? Because we are very close to finalize and close our webinar. And okay, I hope everybody have time to record links to answer the questions. And from right now, we are closing our webinar. Thanks for your interest, and thanks for your participation.